Let us look at the length of the perpendicular from the pole to the tangent to a curve. Okay, let's say this is our function or the curve r equal to f theta. Take an arbitrary point P on the curve. Draw a tangent T at P. Now, as usual, we draw the radius vector. Draw a line N perpendicular to T from O, the origin. So, this is the perpendicular N perpendicular to T. Now, intersection of N and T is at N1. So, this point of intersection would be N1. So, P is equal to ON1 is the length required. Length of the perpendicular from the pole to the tangent. Triangle ON1P is right angled because the N is perpendicular to T. So here it is right angled. Let beta be the angle between the radius vector and the tangent T. And let theta be the angle between the radius vector and the x-axis. P is equal to ON1 is equal to R sine beta. Sine beta is equal to opposite by hypotenuse. That is P by R. So P is equal to R sine beta. So we square it each side and then we take the reciprocal. So 1 by P square is equal to 1 by R square times sine square beta. 1 by sine square beta is cosec square beta. And cosec square beta is 1 plus cot square beta. So now we have 1 by P square is equal to 1 plus cot square beta by R square. We also know tan beta is equal to R times d theta by dr, which implies 1 by tan beta is equal to 1 by R times dr by d theta. So we have taken the reciprocal on both sides. 1 by P square equal to, remember we had 1 plus cot square beta by R square. So cot square beta, and we know 1 by tan beta is cot beta. So which means we take the square of this. So 1 by R square times dr by d theta square. The whole thing divided by R square. So 1 by P square is equal to, now we simplify this, we get 1 by R square plus 1 by R to the power of 4 times dr by d theta square. Now we can actually stop here itself, but if we want, we can simplify it a little bit further. Let's say U is equal to 1 by R, which implies that du by d theta is equal to minus 1 by R square times dr by d theta, which implies du by d theta the whole square is equal to, squaring will make this negative sign disappear. So 1 by R to the power of 4 times dr by d theta square. This is this, and 1 by R square also we can do the necessary substitution. So 1 by P square is equal to U square plus du by d theta the whole square. So either we can take this or we can take this. So that was the length of the perpendicular from the pole to the tangent. And remember, P is an arbitrary point. That means we can move it around. Wherever we take P, the corresponding length, perpendicular length from the pole to the tangent can be evaluated using these expressions. That was length of the perpendicular from the pole to the tangent. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now. Bye.